SOHCAHTOA. And we said yesterday when we were doing SOHCAHTOA that we could use the sine, the cosine, and the tangent anytime we had what kind of triangles? Right triangles. Thank you. So we can only use SOHCAHTOA with right triangles, or triangles that have one angle that's how big? 90 degrees. So they have to have a 90-degree angle. If they don't have a 90-degree angle, we cannot use SOHCAHTOA because that only works, those trig functions only work for our right triangles. So if we don't have a right triangle, we can't use one of our trig ratios. We have to use something else. And so luckily for us, some of those famous mathematicians that we talked about yesterday came up with some other things we can do in order to find sides and angles for triangles that are not right triangles. And so the first one is the law of sines. The law of sines works for any kind of triangle. So it works for right triangles as well as all other triangles. So it doesn't have to be just non-right, but it works for all triangles. And what the law of sines essentially says is if we know a side and the angle that's across from it, so we need to know some sides and some angles, then we can set up an equation where we relate two parts of that to two other parts. So even though here we show all three parts, what the law of sine says is that if you took the sine of angle A and divided it by the side that's across from it, that ratio would be equal to what we'd get if we took the sine of angle B and divided that by the side across from it, and what we would get if we took the sine of angle C and divided that by what's across from it. So just as a reminder, the capital letters are our angles, so the angles are on the top, the sides are on the bottom.
So you're saying if I know the sine of A, the angle A and side A, I could set that equal to B or C.
Right. So what we're looking at here is if this was a triangle, ABC, and let's say this angle was 30 degrees and this side was 10. And we knew that this angle was 31 degrees. We could set up part of this equation to solve and find out what this side was over here. Can we find this angle right now? Yeah, because we can subtract from what? 180. So you can take, I heard 160 again. Somebody else told me that earlier too. So make sure you're subtracting from 180. This triangle is 180 degrees. So you can take 180 minus 30 and minus 31 to find out what this angle over here was. Once we have that angle, then we can find the side across from it as well.
So those lowercase letters are the side across.
This would be if I wrote
right, but in the equation.
Just like we had yesterday,
yep.
Those lowercase letters were the side that's across from it. So in this case, we'd say, if we set this up, okay, well, I want the sine of 30, because that's the angle. Remember, the angles are the big letters. So the sine of 30 over the side across from it, which we said was 10, when I just made that up a minute ago, is going to equal, if I'm looking at C right now, the sine of 31 over the side across from it, which I called little c here and I called x here. Don't be confused, same side. We can call it c there if we wanted to, just to be like consistent. Consistency is probably nice. Okay, now we have it set up like the equations up here. And you only need two of the parts, like I was saying, we don't need all three parts. But now we have a fraction that equals another fraction. And we have had that before. In previous classes, for sure. I think maybe once or twice in this class. But if I saw a fraction equal to another fraction, what might I think to do? Starts with a cross. Cross multiply. Very good. So if I were to cross multiply, that means I multiply the top of that side by the bottom of this side, and the bottom of this side and the top of that side. Does everybody kind of remember that cross multiply thing? Well, this is great because it works for right triangles, it works for non-right triangles. I don't have to pick SOHCAHTOA. I can just use the law of sines every single time if I wanted to, even if it was a right triangle, and I don't need to know which side is my adjacent and which side is my opposite, and I don't have to pick which one I'm going to use. I can take my angle and the side that's across from it, and it's the sine of that angle over the side across from it, and say that that equals another angle and the side across from it. And now I can just cross multiply those, so I have c times the sine of 30 degrees equals, because that's what I get when I multiply those, 10 times the sine of 31 degrees. And I want somebody brilliant to tell me what could I do with this sine of 30 to get c by itself. I could divide both sides by the sine of 30.
Because remember, that just gives you a number.
And this will cancel out. And I'll get c equals. And I can plug all of this loveliness into my calculator, which I gave to Kayla. So I cannot really plug all of that.
And don't forget to do the top in parentheses.
But if I were plugging that loveliness into my calculator, I would have 10 sine 31, make sure I'm in which mode? Degree, over sine 30. And I would get some answer, what is it? 10.3. So c equals 10.3, which means this side was 10, and this side is 10.3. That makes great sense to me, since this angle is 30, the side across from it is 10. This angle is just a little bit bigger, so the side across from it is just a little bit bigger. And we could even find angle B, because we could subtract from 180 and then just do this again to find the side across from it. So I have another example here for you to just look at. One more try. Some of our examples will be like the one I just gave you, where they drew the triangle for us. And in some of them, we're going to have to draw our own triangle. So they're going to tell us, in some triangle ABC, angle A equals 30, side from A to B equals 8, and the side from B to C equals 5. Find all of the rest of the information. Okay. So what I would do then is draw myself a triangle. And it doesn't matter what your triangle looks like. I could draw this triangle, or I could have drawn this triangle, or I could draw this triangle. We don't really know what it's going to look like. What we know is that the angles are going to be labeled A, B, and C. So we're going to go ahead and label our angles A, B, and C. From the information that we are given, we see that angle A has to equal 30 degrees, so that means this guy up here in this particular one, 30 degrees. We know the side from A to B equals 8, so that's this side from A to B, remembering our geometry now, is 8. The side from B to C equals 5. And now it's too bad we don't know that's a right triangle, or we could use Pythagorean's theorem, but we don't. So don't use Pythagorean's theorem here, because we don't know that. Yes, ma'am?
Does that say SCM?
5 centimeters.
No, don't
8, sorry. 8 centimeters. Okay, so we're going to set up our problem using that sine law that we had at the top. So I said, okay, well, the side, the angle that I know are A. So I know the sine of 30 goes over the 5, because they're across from each other. And then I don't know the angle that's going to be C, but I know the side across from it is 8. So this time I'm missing the angle on the top. So I'm going to say, okay, well then it's the sine of C, big C, that I don't know yet, over 8. I'm going to solve exactly like I did a minute ago by cross multiplying. So I'm going to take 30, sine of 30 times 8, 5 times the sine of C. And I would just get 8 sine 30, we'll skip this guy for a minute, equals 5 times the sine of C. And I want to get rid of this 5, so just like I divided before by the whole sine thing, I'm just going to divide by the 5 on both sides. Which just gives me 8 sine 30 over 5 equals the sine of C. And now I can plug all of this stuff into my calculator, and I should get some lovely decimal answer. Like 0.8, beautiful. And yesterday we talked about this. We got to 0.8 equals the sine of C. Do we know how big angle C is yet?
No.
No, because it's angle C 0.8, Miss Boyer?
No, the sine of angle C is
The sine of
0.8.
angle C is 0.8. So we're going to look at our calculators, look at our sine button, and find out what's the opposite of sine?
The
Sine
inverse.
inverse. So we are going to take our 0.8 and we're just going to plug it in with the sine inverse.
Oh, how do I get that on my calculator, Miss Rumsey?
How do I get that on my calculator? That is very tricky. Does anybody know? Second sine.
That's it? Second sine?
Oh my goodness, boy, you are extra animated this morning.
You should wait till you see the animations in the
Second
video.
sine. I'm so excited. 0.8. And now we should get a number that's closer to like 53.
Oh, that's a better angle.
That is a better angle. Once I have that particular lovely angle, and I plugged that into my triangle here, couldn't find it for a minute. So this angle equals 53-ish.
Could you slide that up?
Angle equals 30-ish. Oh, I'm so sorry. Thank you. So if this is 30 and this one's 53, we can find B by just subtracting from what again?
180.
180. Right? And then we can find our side that's missing by doing a problem using the sine law again for the final piece. Are these long problems? Yes, yes they are. Are they easier for some people than using the trig functions and having to know which one? For some people, they're way easier than using the trig functions. Anybody else have a question or a thought on those before we try the law of cosines? Okay, so the law of sines, straightforward ratio between the two.
And if I like this better, I could use this on my homework tonight, couldn't I? On that handout.
I could do that.
It's a little easier if you like ratios.
It is, and it's really easy because you don't have to figure out which one to use.
Right.
Bonus. Do you want to do a second video for law of cosines?
Oh, I would love to.